Welcome to our channel. Today, we're diving into the heart of our solar system to uncover some mind-blowing facts about the sun. You know, that giant ball of plasma that keeps us all alive? Yeah, that one. It's more than just a bright light in the sky. We're talking about the kind of mind-blowing facts that make you question everything you thought you knew about space. Did you know, for instance, that the sun's atmosphere is actually hotter than its surface? Like, millions of degrees hotter. It's true, and today we're going to find out why. So, buckle up, space cadets, because we're about to embark on a journey to understand the star of our show, the sun, in ways you've never imagined. Stay tuned, because you won't believe what we've discovered. Alright, let's talk about something truly bizarre. The sun's corona, that ethereal halo we see during a total solar eclipse, can reach temperatures of millions of degrees. Millions. Now you'd think that being closer to the source of all that heat would mean you're, well, hotter. It's like standing closer to a campfire and feeling warmer, right? But the sun doesn't play by those rules. The surface of the sun, called the photosphere, clocks in at a balmy 10,000 degrees Fahrenheit. Hot, yes, but a far cry from the scorching temperatures of the corona. So what's going on here? How can something that's further away from the sun's core be hotter than the surface? Well, that's one of the biggest mysteries in solar physics. Scientists have been scratching their heads over this for decades. One leading theory points to a phenomenon called nanoflares. These are like tiny explosions, millions of them happening all the time across the sun's surface. They're thought to release massive amounts of energy, heating the corona to those incredible temperatures. Another theory suggests that magnetic waves generated deep within the sun carry energy outwards and deposit it in the corona. Imagine these waves like surfers catching a wave and riding it all the way to shore. Only in this case, the shore is the corona, and the surfers are packets of energy. These are just two of the many theories scientists are exploring. It's a puzzle that keeps them up at night, and for good reason. Understanding how the corona gets so hot could unlock secrets about the behavior of stars across the universe. It's a reminder that the sun, for all its familiarity, is a complex and mysterious object. We've been studying it for centuries, and yet it still has the power to surprise us. And that's what makes solar physics so exciting. We often picture the sun as this perfectly round, giant ball of fire, and it's true, from our vantage point it does look pretty darn spherical. But here's the thing, the sun isn't perfectly round, it's actually a little bit squashed. Now before you start picturing the sun as some kind of cosmic pancake, let me explain. The difference is incredibly small, almost imperceptible, but precise measurements have shown that the sun's diameter at the equator is just a tad bit wider than its diameter from pole to pole. We're talking about a difference of only about 6.2 miles, 10 kilometers, over a whopping 865,000 miles, 1.39 million kilometers. That's like noticing a single extra grain of sand on a beach that stretches for miles. So what's causing this slight flattening? You guessed it, it's all about spin, baby. The sun rotates on its axis just like Earth does. But unlike Earth, which takes a leisurely 24 hours for one rotation, the sun spins much faster. Well, it depends on what part of the sun we're talking about. You see, the sun isn't a solid object like Earth. It's a giant ball of plasma, and different parts of it rotate at different speeds. The equator spins faster than the poles, completing a rotation in about 25 days, while the poles take a more leisurely 36 days or so. This differential rotation, as it's called, creates a centrifugal force that pushes outward, ever so slightly distorting the sun's shape. It's like spinning a ball of dough. The centrifugal force causes it to flatten out a bit. Now you might be thinking, okay, so the sun is a tiny bit squished. Who cares? Well, this seemingly insignificant detail actually has important implications for our understanding of the sun's internal structure and its magnetic field, which, as we'll see later, is a pretty big deal. We've all seen those beautiful auroras, those shimmering curtains of light that dance across the night sky at high latitudes. But have you ever stopped to think about what causes them? What cosmic artist could paint such a breathtaking spectacle? The answer, my friends, lies with our very own star, the sun, or more specifically, the sun's incredibly vast and powerful magnetic field. This magnetic field is like an invisible force field that extends far beyond the sun itself, encompassing all the planets and beyond. We call this vast expanse of magnetic influence the heliosphere, and it acts as a sort of cosmic bubble, shielding us from harmful interstellar radiation. Think of it as our own personal force field against the dangers of deep space. But the sun's magnetic field isn't some static, unchanging entity. Oh no, it's a dynamic and ever-changing beast, prone to fits and bursts of activity. Sunspots, those dark, cooler regions on the sun's surface, are a prime example. These blemishes on the sun's complexion are regions of intense magnetic activity, where magnetic field lines twist and tangle, trapping plasma and inhibiting the flow of heat. And when these magnetic fields snap and reconnect, they can release tremendous amounts of energy in the form of solar flares and coronal mass ejections. Imagine 1 billion atomic bombs exploding simultaneously. That's the kind of energy we're talking about. These solar storms can hurl massive clouds of charged particles known as plasma across the solar system at speeds of millions of miles per hour. And when these charged particles collide with Earth's magnetic field, well, that's when the real show begins. The auroras we marvel at are a direct result of these charged particles interacting with atoms in our atmosphere, exciting them and causing them to glow. But the sun's magnetic field isn't all fun and auroras. These solar storms can also wreak havoc on our technological infrastructure, disrupting satellites, knocking out power grids, and even posing a risk to astronauts. The sun isn't going to be around forever. Like everything else in the cosmos, it has a life cycle. And while it's currently in its prime, happily fusing hydrogen into helium, and providing us with the light and warmth we need to survive, this won't always be the case. Billions of years from now, the sun will undergo a dramatic transformation, one that will have profound implications for Earth and the entire solar system. It's time to talk about the sun's inevitable fate, its transformation into a red giant. Don't worry, this cosmic switcheroo won't happen overnight. The sun has about 5 billion years left in its current stable state. But after that, things will start to get interesting. As the sun continues to fuse hydrogen in its core, it gradually exhausts its fuel reserves. And as hydrogen runs low, the core begins to contract under its own gravity, causing the temperature and pressure to soar. This, in turn, causes the outer layers of the sun to expand outward, like a balloon being inflated. And I mean really expand. The sun will swell to an enormous size, engulfing the orbits of Mercury, Venus, and yes, even Earth. Our planet, bathed in the intense heat of the expanding sun, will become uninhabitable, its surface scorched and oceans boiled away. But it's not all doom and gloom. As the sun expands, it also cools, its surface temperature dropping to around half of what it is now. This cooling will cause the sun to glow a deep red, hence the name red giant. While this phase marks the end of the road for Earth, it also marks the beginning of a new chapter for other worlds in the solar system. The icy moons of Jupiter and Saturn, once locked in a perpetual freeze, will thaw, their surfaces potentially becoming hospitable to life. The sun's transformation into a red giant is a powerful reminder of the impermanence of even the most seemingly eternal objects in the universe. It's a reminder that change is the only constant, and that even stars have their own life stories to tell. We've talked about the sun's scorching heat, its powerful magnetic field, and its eventual fate as a red giant. But what is it about the sun that allows it to generate such immense amounts of energy that sustains life on Earth and drives the dynamics of our entire solar system? The answer, my friends, lies in the heart of the sun, where a process of unimaginable power unfolds: nuclear fusion. Deep within the sun's core, under unimaginable pressures and temperatures reaching millions of degrees, hydrogen atoms are being forced together, fusing to form helium. Now, this isn't your typical chemical reaction like burning wood or exploding dynamite. No, this is a nuclear reaction where the very nuclei of atoms are being altered, releasing tremendous amounts of energy in the process. Think of it like this. Imagine trying to push two magnets together, North Pole to North Pole. You feel that resistance, that force pushing back against you? That's the electromagnetic force at work, preventing the like charges of the magnets from getting too close. Atoms have a similar kind of resistance. Their nuclei, made up of positively charged protons, repel each other. So how do you overcome this electromagnetic repulsion and force those protons close enough together for them to fuse? That's where the extreme conditions in the sun's core come into play. The immense pressure and temperatures provide the energy needed to overcome the electromagnetic repulsion, forcing those hydrogen nuclei so close together that they eventually overcome the strong nuclear force. And when that happens, boom! The protons fuse, forming a new helium nucleus and releasing a tremendous amount of energy in the form of gamma rays. These gamma rays then embark on a long and arduous journey from the sun's core to its surface, constantly interacting with matter, being absorbed and re-emitted at lower and lower energies. By the time they reach the surface and escape into space, these gamma rays have transformed into the sunlight we know and love, providing us with light, warmth, and the energy that drives life on Earth. Thanks for watching. If you enjoyed these surprising facts about the sun, don't forget to like, subscribe, and hit the bell icon for more amazing content. We've journeyed from the sun's scorching corona to its churning core, uncovering the secrets behind its immense energy, its surprising shape, and its inevitable fate. But our exploration of the cosmos is far from over. There's still so much more to discover, so many more mysteries to unravel. So join us next time as we continue our exploration of the universe and all its wonders. See you next time.